Hello guys, my name is Bob. In this video I'm going to show you the solution to the Maclaurin series of cosine square x using the top right hand corners formula. The top right hand corners formula tells us that a function can be expressed as an infinite series called the Maclaurin series. Before I show the answer, don't forget to help us or help me to subscribe to this channel for more Maclaurin series problems and integration problems. And if you guys do like this solution, press the like button, alright? So let us begin by solving this problem. So before we are able to express the Maclaurin series, we have to first find the following, which is the function evaluated at x is equal to 0, the function differentiated one time and evaluated at x equals to 0, the function evaluated at 2 times and at x equals to 0, function differentiated 3 times and find the value at which x is equal to 0, and function differentiating 4 times and find the value at x equals to 0. So we shall now begin by finding the Maclaurin series. We first let the function of x be equals to cosine square x, and then we find the differentiation of the function of x. We will get negative 2 cosine x sine x. We next find the function differentiated twice. So how do we go about doing it is we have to do the product rule of differentiation in this form. Alright, let me just write in full in this form. Okay, and then we evaluate it. So the first term we get negative 2 cosine square x. The second term we get I think it was plus 2 sine square x. Alright, after which we find the function differentiated 3 times. We will get the following. The first term would be just negative 4 cosine x, differentiating the cosine x trigger, we will get negative sine x, plus 4 sine x, differentiating the trigger sine x, we get cosine x. So the two terms are actually exactly the same. We were summing up, we will get 8 sine x cosine x. Okay, so this basically can be expressed in terms of the function above. So x sine x cosine x is also the same as negative 4 times negative 2 sine x cosine x, in which you know that negative 2 sine x cosine x is actually my f1x. That means the function differentiated one time. Last but not least, we find f4x. So that means the function differentiated at 4 times. So that is equivalent to negative 4 differentiated with respect to x of f1x. So this is pretty straightforward. It's negative 4 differentiated of negative 4 function differentiated twice. Okay, so we have all this solution. We can actually go ahead to evaluate at x is equals to 0. So for the first one, f0 is actually equals to 1, because cosine x basically is equals to 1 when you substitute x is equals to 0, while f1 evaluated at x equals to 0, we will get basically 0 because sine x is 0, so anything times 0 is 0. f2x is basically just negative 2, because my first term is actually negative 2, my second term is 0 because sine 0 is 0. f30 is equals to negative 4 f10. We know that f10 is 0, so f30 is basically just 0. Last but not least, f40 is basically equals to negative 4 f20. f20 we know that is negative 2, so negative 2 times negative 4 is 8. And after which we can actually use this solution and substitute into the formula in the top right hand corner to find what is my Maclaurin series of cosine square x. So the Maclaurin series of cosine square x is basically 1 subtracting away 2x squared over 2 factorial plus 8x to the power 4 over 4 factorial. So we are evaluating up to the x to the power 4 terms. So this is also equals to 1 minus x squared plus x to the power 4 over 3. This is a final answer to the Maclaurin series of cosine square x. If you guys like this solution, press the like button. Thank you guys for your support, and don't forget to subscribe to this channel. Thank you guys for watching.